example 7. Okay, the first question, find the angle between the planes x plus y plus z equal to 1 and x minus 2 plus 3z equal to 1. So now from the two equation, the plane has two normal, which is the first normal vector is 1, 1, 1, and the second one is 1, negative 2, 3. Okay, so we know the formula to find the angle between the plane is cos theta equal to normal vector 1 times normal vector 2 divided by the magnitude of normal vector 1 times with magnitude of normal vector 2. So we just need to find the theta. We can bring the cos into this side and the cos will become theta is arc cos normal vector 1 normal vector 2 divided by magnitude of normal vector 1 times with magnitude of normal vector 2. So we can just simply substitute the value of n into the formula. Okay, so we just solve it, and this part we can solve it by using dot product. So theta is equal to cos negative 1 2 divided by square root of 3 times with square root of 14. So we can just simply use calculator to calculate the value of theta, and we get the value of theta is 72 degrees. So the angle between the plane of x plus y plus z equal to 1 and x minus 2y plus 3z equal to 1 is 72 degrees. Now I'm going to show you how to solve the second equation for the example 7. The equation is, find the symmetric equation for the line intersection L of these two planes. So this is our first plane, which has the equation x plus y plus z equal to 1. And this is our second plane that has the equation x minus 2y plus 3z equal to 1. So first we need to find where is the line intersection of L. This is the line intersection of L. So before we find the symmetric equation, first we need to find a point in this line. So we can find the point in this line where the line intersect xy plane by setting the value of the value of z equal to 0. So we can have the equation, the new equation, which we substitute the value of z equal to 0. We can get x plus y is equal to 1, which we can set it as the first equation, and second we can get the equal to 1, and so from the first equation we can find the third equation, which is x is equal to 1 minus y. So from these three equations we can find the value of y by setting 3 into the second equation. So it will be 1 x minus 2y equal to 1. So 1 minus y minus 2y is equal to 1. So y is equal to 0. So from this we get the value of 0. So now to find the value of x, we just need to substitute the value of y into the third equation, and we get the value of x is equal to 1. Okay, so now we let the point in the line of in the intersection of L by P. Let the point intersection by P. So we get the point 1, 0, 0. So we know that we have two normal vector from the we can get two normal vector from these two equations. That is, normal vector 1 is equal to 1, 1, 1, and normal vector 2 is equal to 1, negative 2, 3. So from here we can see that the L line, the intersection of L, lies in the both plane. So we know that the line is perpendicular to the both normal vector. We know that there is a vector v that is parallel to the line that given by vector v is normal vector 1. We cross it with normal vector 2. So we can just solve it until we get the equation of vector v. We put the normal vector 1 value, which is 1, 1, 1, and we put the normal vector 2 value, which is 1, negative 2, and 3, and we solve it. So we get the vector v equation is 5i minus 2j minus 3k. So from this we know that the symmetric equation is given by the symmetric equation is x minus x naught over a equal to y minus y naught divided by b equal to z minus z naught divided by c. So the value of x naught, y naught, and z naught intersection in the line of L, that is the value of x naught, y naught, and z naught. And for the value of a, b, and c, we can get from the equation of vector, which is this as a, this b, and this c. Sorry. So we can write our symmetric equation like x minus 1 divided by 5 equal to y minus 0 divided by negative 2 and equal to z minus 0 divided by negative 3. We can just simplify it and become, let me just write it in here, and we can get the symmetric equation x minus 1 divided by 5 equal to y divided by negative 2 equal to z divided by negative 3. So this is the symmetric equation for the line intersection L of these two planes.
Assalamualaikum. Okay, today I'm going to show the answer for example 8. Okay, the question is find a formula for distance d from a point P1 with coordinate x1, y1, z1 to the plane ax plus by plus cz plus d equal to 0. Okay, first we let P naught with coordinate x naught, y naught, and z naught, and we let b be a vector that corresponding to P naught P1. Then we can write b is x1 minus x naught, y1 minus y naught, z1 minus z naught. Okay, we can draw. Okay, this is a plane. This is a P1. This is a P naught. Can draw like this. Okay. This is a B, and this is a distance, and this is also a normal vector. Okay, we can see the d from P1 to the plane is equal to absolute value of scalar projection B onto normal vector n, which n with coordinate A, B, C. So the formula for distance is magnitude component B along n, and we can write also as magnitude n times B divided by magnitude n. Okay, we substitute the value of n and b, which n is a, b, c, b is x1, minus x naught, y1 minus y naught, z1 minus z naught, and divided by a, b, c. And we expand and write it like this. x1 plus by1 plus cz1 ax naught plus by naught plus cz naught. The P naught lies on the plane. Its coordinate satisfy the equation of the plane. So we have ax naught plus by naught plus cz naught plus d equal to 0. We also can write this equation ax naught plus by naught plus cz naught equal to negative d. So we can see this equation is equal to this. So we substitute negative d in this equation. So we can get the formula ax1 plus by1 plus cz1 minus negative d divided by x squared plus b squared plus c squared. We simplify, we get ax1 plus by1 plus cz1 plus d divided by square root a squared plus b squared plus c squared. So this is the formula for the distance d from point P1 coordinate x1, y1, z1 to the plane ax plus by plus cz plus d equal to 0. Okay, thank you. That's all from me.